Hello, introductory video on circles, tangents and normals. Quite a lot of the time we're interested in finding the tangents to curves and the normals to curves, and a good place to start on this is with circles. So we all know what a circle is here. We've got our circle, we've got a radius. We can have a tangent line here, which is one of those lines that just touches the circle, and then we can have the normal line here, which is at right angles to tangent, which in the case of a circle is going to be an extension of the radius. So what we're going to do is look at these, and we're going to use our general equations with straight lines that we did in the previous video to explain all this. Okay, let's start with the general equation of a circle. Well, the best way to look at this is to think about, we've got the center of a circle here, x little c, y little c, and all the points on the circle are distance r away from it, so any point x and y. So that means we can create a little triangle here, can't we? The base of the triangle is x minus xc, and the height of the triangle is y minus yc, and the hypotenuse is always r. So if we just apply Pythagoras to that lot, then x minus xc all squared plus y minus yc all squared is going to equal r squared. So our life is pretty straightforward there, and that's the general equation for a circle from the radius and the center x and y. Okay, so let's have a look first at creating a tangent. Well, the first thing we've got is we've got our radius. Here's our radius here, and yeah, again we can create our little radius triangle in the red here. Now the tangent line here, the green line, is always at right angles to the radius. There we go, that's our right angle. Why is it always at right angles? Well, if it wasn't at right angles, have a look like this, it would make contact again with the circle here, wouldn't it? And we would have a little isosceles triangle here, and of course if it's a tangent it's only going to touch it, it can't touch it in two places, so therefore it must be at right angles. So let me get rid of that, just so we can see what we're doing. And if it's at right angles, then in effect it's a bit like we saw on perpendicular straight lines. Here we've got two similar triangles, haven't we? There's one and there's the other one on the triangle, so this angle here must be the same as that angle there. And as we saw before in the previous video, we can quite quickly see that if this has got a gradient m, the radius, then the tangent line must have a gradient of 1, so minus 1 over m, the reciprocal of m. Yeah, and that's what we're going to use. Okay, so let's use an example just to see what we're doing. We've got a center, it's at point 1, 2, and we've got a point on the circle which is at 4, 6. Therefore, with a radius of 5 here, we can create our little triangle here, which is in this case a 3, 4, 5 triangle. That's our radius triangle, isn't it? And if we then take that triangle and rotate it clockwise 90 degrees, we've got this triangle here, an equivalent triangle, and so the 3's on there and the 4's there, isn't it? So we can quickly see that because it's at right angles, the radius, so let's start off first with the gradient of the radius is 4 over 3, and the gradient of the tangent is a minus 3 because it went down, didn't it, over 4. That's our up over along, our change in y over our change in x. Yeah, so we've got our radius gradient looks like that, and our tangent gradient is minus 1 over the radius gradient, so that's minus a 3/4. Of course, we can now drop that into our standard format for a straight line, and remember we did this before, that because we've got the similar triangles, then the change in y is going to be the change in x multiplied by the gradient, isn't it? So if we're going through a point here, 4, 6, we found what our gradient was already for our tangent was minus 3 over 4. And so we're just moving away, our y is moving away from the base point of 6, and our x is moving away from the base point of 4. So that was, again, a very simple way of creating our tangent line, and we could, of course, simplify it if we wanted to, if they asked us to present it in an exam without the fractions, with all the integers, we'd simplify it to that. Okay, well, what about the normal line? Well, the normal line here is this radius line. Okay, so we worked out earlier in this example that the gradient here from our gradient triangle is 4/3, so we can put that in as our gradient, and we know that this line goes through the point 4, 6, so we can just put in for our y minus 6 in that bracket and x minus 4 in that bracket, and if we simplify it we just end up with 3y minus 4x equals 2. Okay, so let's summarize where we are with circles and general equation. Remember, we're just getting that from Pythagoras, and we're finding a point on the on the circle compared to the center, and it's got to be a distance r away, which is going to be the hypotenuse. Okay, the tangent's going to be perpendicular to the radius line, so therefore we're going to have one of our, if it's going to be 1 over m for the radius, isn't it, will be the gradient of the tangent, and the normal is just an extension of the radius line, so that's just going to have the gradient of the radius, isn't it? There we are. I hope that's of use to you.